Imagine a sci-fi movie where scientists are able to detect cosmic messengers billions of light years away using a detector in ice at the bottom of the world. Except, it's real. Welcome back to Tiny Ice. My name is Jocelyn, and this is where I share bits for my trip to Antarctica. If you're new here, I went to the South Pole as a PolarTREC educator. You can find more information about them below. And today we're going to be talking about the whole point of my trip, which was to visit and work with the IceCube Laboratory, located at the South Pole. When I first learned about this project, I was on a ferry watching a video about it when I felt my head start spinning, and it wasn't from the seasickness, but it was from trying to wrap my head around this incredible project. I mean, come on, we're able to study the cosmos from detecting these tiny elusive particles that come from billions of light years away. We're mixing an already ambitious goal with one of the harshest, most unique environments on the planet. Cool is an understatement. So let's get to it. It's time to talk about the IceCube Neutrino Observatory. Ready? Let's go. The IceCube Neutrino Observatory is a telescope, a very large telescope that's made up of over 5,000 round detectors called DOMs, or digital optical modules. These are part computer, part light detectors. These are attached to 86 strings and frozen about 2.5 kilometers deep inside the ice. In all, the observatory takes up a cubic kilometer of space. At the top of this is the IceCube Laboratory, an icy blue building that collects all the data from the action happening below the surface, and then sends it via satellite to scientists of the IceCube Collaboration that are located all around the world. Next, what are we detecting? The observatory is looking for neutrinos, which are tiny, nearly massless particles that are born in violent, high-energy events out in the universe. Think black holes and supernovas, and these can be billions of light years away. On rare occasions, these neutrinos bump into atoms below the ice, and when they do, they give off a burst of light that's detected by the DOMs and then sent up to the IceCube Laboratory. And finally, how does this help us study the universe? The interesting thing about neutrinos is that they travel in a straight line until they bump into an atom. So when IceCube detects a neutrino below the ice, we can follow its direction back up to space and possibly find something big happening in the universe. It's like a powerful reverse astronomy experiment where instead of looking into space and finding something new, we're waiting for these particles, or neutrinos, to reach us so we can trace the path back to the source. The IceCube Neutrino Observatory is amazing, and we're really only scratching the surface here, so I'll go ahead and link their information down below. They have a lot of great outreach material on their website and places where you can learn more. And of course, you can always message me on social media and ask me any questions. I'd love to help you find the answer to them. IceCube also just released an augmented reality app where you can see these neutrino events that are happening under the ice and project them anywhere around you. I'll link that below too. It's a lot of fun, and I gotta warn you, kind of addicting. Thanks for stopping by for some Tiny Ice. Stay tuned for more bits from my trip to Antarctica. See you later.